Hi, my name is Michael O'Connell. I'm the Technology Sales Manager for the Americas regions for L.B. Foster. I'm here to talk to you today about our new product line, Total Track Monitoring. L.B. Foster has been supplying the rail industry for over 100 years. Our headquarters is in Pittsburgh, but we have locations throughout North America and Europe. Our first product line revolves around our Insight LiDAR. It's got a 100-foot radius and it does 190 degrees of viewing angle. It refreshes at 20 Hertz, so it's a very accurate system. Here you can see the Insight LiDAR in a side-by-side comparison for a grade crossing application where you have the video on the left and the Insight LiDAR on the right. You can see that the accuracy of the LiDAR is able to pick up individuals' legs as they're walking through the crossing, and we're also able to differentiate between sizes of object as well. This is the layout of a grade crossing monitoring installation that you can position the LiDAR either between the tracks or off to the side. You can see that the LiDAR is tracking vehicles and pedestrians through the grade crossing detection zone, and we're able to use this information to dynamically control 4-quadrant grades, look for trespassing violations, and then also look for potential block crossings as well. Rockfall monitoring is an area where we are using LiDAR to replace the slide fences. So slide fences have a lot of issues with false positive rates, and we're using LiDAR to scan above the track so that we're looking for rocks of a certain size determined by the railroad that are on the track and could potentially cause a risk to the train. So here for embankment monitoring, we're actually using the LiDAR to actually measure instead of using it for obstacle detection. We can take this LiDAR, position it at the slope, and look at daily, monthly, or annual movement differentials. We can remove the vegetation for the slope so that the LiDAR is actually measuring just the slope itself. And then we can also look at the volumetric movement of land if there is any type of slippage or landslide. So here's a recent example from one of our installations where we have circled in blue, we have a heavy rainfall event. And then hours later, we have some sliding of the slope, and then we have a major slide event. So this is something that we can set alarms to and set warnings to as well. If there is a risk situation, we can start looking at the analytics of it. So the next product line is remote condition monitoring. Remote condition monitoring works all off this base station hub, where we can power this hub, this communications hub, off solar, battery, or direct power. And we are also able to couple this with a HD PTZ camera as well. So Avalanche and Landslide Detection, which are part of the RCM suite, use our inline tilt tag to look for avalanches and landslides. On the right, you'll see an avalanche detection application where we have our tilt tags on top of breakaway poles, looking for an avalanche to come through and knock over the poles. And then on the left-hand side, you see the landslide configuration where we have the tilt tags connected to shorter posts that are actually embedded in the ground. Our inline floodpole is part of flood monitoring. It's a capacitive design that's fully submergible, and you're able to set custom alarm points along its length. No water actually goes inside the pole, and all the sensing is external, so there's no moving parts. It's battery powered and has half-mile wireless communication range. Here's a recent event that we caught for a warning alarm that came up on this pole. You can see that the camera automatically pan, tilt, and zoomed to this area, took a picture, and sent an email out at 4:20 in the morning. You can see with that photo as well, we also started recording an event. And so this is what the event that took place. You can see that the water quickly rose to 4 inches and then quickly went back below the 0-inch mark on the pole. After the water receded in the morning, we took more pictures to take a look at the site and give that information to the railroad so that they could take the necessary actions. But you can see that the system was able to record and understand what the event that took place at 4:20 in the morning when nobody was out there to inspect. So that's all I have today. If you have any more questions, you can see my contact information in the bottom right-hand corner. Thanks for listening.